Good morning, afternoon, or evening. How y'all doing today? Welcome back to Mr. Morrow's Algebra 2 class. Today, guys, we're going to continue with our logs and exponential chapter, and we're going to talk about composite functions and inverse functions. Before we can learn that, we have to a little bit go back in the past, okay? First of all, I want to make sure that you guys understand that a function, just a pure function, is any relation where there can only be one y value, one dependent value or variable for any given x value, okay? So on a table, if you have 2, 5, and then 2, 3, you cannot do that because the x value of 2 had two different y values. One of 3, one of 5, that is not a function. Another thing that's old, this is all stuff that we've done before. The symbol f of x represents the dependent variable, y. So in essence, f of x does equal y. The f of x is read f of x, which means function f with independent variable x. The x is in the independent, okay? The f of x is the function itself, that is the y. Now, do you guys remember how to evaluate the following? If I tell you f of x equals 2x minus 3, then find f of negative 2, what did I replace that x with, y'all? So what am I going to replace the x with? I love it when that happens. What am I going to replace the x with? Okay, now maybe we'll do it one more time. Let's see. Be like a little game today. Okay, so this is going to be 2 times negative 2 minus 3. So that's going to be negative 7. What about if I said to you f of w? What did I replace the x with? So what am I going to replace the x with? So this will be 2w minus 3. Everyone remembers that, right? Pretty simple, easy. You just plug it in. Perfect. Hopefully you guys remember all of this as well. F plus g of x just literally means function f of x plus function g of x. F minus g of x literally means function f minus function g. Multiplication, f times g of x literally means f of x times g of x. And f divided by g of x literally means f of x divided by g of x. It's that simple. That's all stuff we've done. So let's do a little bit of work here. Let's go find f plus g and then determine the domain. Okay. So f plus g. I've got f of x, which is 3x squared plus 2, plus g of x, which is x minus 5. So f plus g of x will equal 3x squared plus x minus 3. Now, what's the domain here? Good job. Yes, it is a quadratic function. Good job, guys. Right. Yes, exactly. And a quadratic function is a U-shaped graph. That's right. And I did tell you that. Good. Quadratic functions are always all real numbers. Why? Well, if you remember, this graph here is going little by little to the right, and this side is going little by little to the left. So that means that all of the x's will be encompassed. In fact, if you guys remember, the domain of any function is always going to be all real number, except there were 3 exceptions. What were the 3 exceptions for the domain? Right. Number 1, if f of x equals something with a variable in the denominator, I must set the variable to not equal 0, and that's going to be my domain, everything except for that number. Another case is if you have x inside of a square root. If you have x inside of a square root, you can only have positive values inside of there. So you set the radicand, what's inside the radical, to greater than or equal to 0. Then that would be your domain. And last but not least is if you have a function f of x where you have a variable in the denominator and it's in a radical. So if I have square root of x down here, then your domain, this cannot be 0, but it has to be positive. So x must be greater than 0. And then you have your domain. So those are your three restrictions. So whenever you have a function and they ask you for a domain, it is going to be all real numbers unless there's an x in the denominator. Set that not equal to 0. The domain is everything except for that. Unless x is inside of a square root, then you must set the radicand to greater than 0. Unless you have an x in a square root rather, in the denominator, then you must set it to just greater than 0. If I want f minus g, okay, I want f of x minus g of x, I want you to determine the domain. Well, in this case, it's going to be 3x squared plus 2 minus g, which is x minus 5. Please remember, you must distribute that. So this will equal 3x squared minus x plus 7. Thank you. And what would the domain be? All real numbers. Why? Because you don't have any of the restrictions that I just finished talking about. Okay, so let's move on. Yes, sir. Okay, let's see. Hold on. Well, my domain for sure. Now, my boy's asking me about range. Okay. In this particular case, my range, not from -3. Remember that -3 is going to be your y-intercept. So your range would be determined by your vertex. You'd have to find your h and k, your vertex, and then that y value, that is either going to be the lowest point or the highest point. And in this case, since it's positive, it's going to be a minimum. There's going to be a minimum somewhere. So to find the range, you have to find the vertex first. And then from the y, you either go up or down, depending on the graph itself. Correct, my brother. Correct, my brother. Excellent. Okay, thank you, my man. All right, how about this? Let's find f times g and then determine the domain. All right, so I got x squared minus 4, that's f, times g, which is x plus 2. Well, FOIL. So this is going to be x cubed plus 2x squared minus 4x minus 8. So this is going to equal x cubed plus 2x squared minus 4x minus 8. That's it. It's that simple. What's my domain? Thank you. It's all real numbers. Why? Because I don't have any variables in the denominator or in a radical or in the denominator and a radical. I don't have that. And last but not least, f divided by g. So I got x squared minus 4 divided by x plus 2. Okay. So x squared minus 4 divided by x plus 2. Okay, easy. Can I factor that numerator? Okay, what is that? That's a blank of blanks. Difference of squares, excellent. So this is an x plus 2 over x minus 2. You have x plus 2, cancels. My answer is x minus 2. Or you could have done synthetic division or long division as well. So everything we just did here, guys, it's all stuff of the past. We've done this all. So let's move on to the future. Composite functions, or composition of functions. Today, guys, we're going to deal with f, and then you have this little o here. Okay, it is not a multiplication. It is called a composition. I call that fog because it's an o, not a multiplication. And then over here, that's goff. So I fog and goff helps me remember. Okay. Now, what the heck do these mean? Well, f of g of x means f of g of x. So what's happening is I'm replacing the g of x function into every value of x in function f. When I find g of f of x, I take the value, the function f of x, and I am plugging it in to the function of g. So I'm literally replacing one function into the other. For example, How does it work? If I want to find f of g of x, I first evaluate g of x, find out what it is. Then I evaluate f of x using the value of g of x as my x. I'm replacing my x with g of x. For example, I want to find gof of negative 4, g of f of negative 4. Well, this is g of f of negative 4. So the first thing I got to recognize, what am I replacing the x of function g with? Read it right there, guys. This is g of x. What am I replacing the x in function g with? F of, no, not f of x, no. F of negative 4. So first thing, what's f of negative 4? F of negative 4 is going to be negative 9. So now I have g of negative 9. And what's g of negative 9? It'd be negative 9 squared, which equals 81. That's gof of negative 4. I found my f of negative 4, and then I literally plugged it into the x value of function g. Yes, sir, my brother. From f of negative 4, my man. F of negative 4, negative 4 minus 5 equals negative 9. Thank you so very much for your honesty. Yes, sir. I would not do that, because if they're going to do extra work, if you plug in f of x into g of x and then plug in the 4, think about it. You're turning something simple into more complicated and then plugging in the 4. Now, can you do that? For sure. I wouldn't.
Yeah, I'm just saying, like he just said, how did you get the negative 9? They probably won't.
Well, then if they can't understand it, then they will fail. But they got the negative 9 because it's clearly f of negative 4. So that's just what we talked about in the last two seconds ago. Guys, if you don't know how to do step 1, step 2 is going to be very difficult. So, yeah, thank you, though. I appreciate you caring. And good question. Thank you. Okay, how about fog of negative 2? I want f of g of negative 2. So f of g of negative 2. Guys, what am I replacing the x of function f with? No, not g. G of negative 2. Guys, there's a huge difference. G is the function. Negative 2 is the x. I'm replacing every x of function f with the value of g of negative 2. What is g of negative 2? Yeah, negative 2 squared is 4. So now I'm finding f of 4. What's f of 4, boys? 4 minus 5 equals negative 1. Ping, pong, boom, you're done. Does that make sense, gentlemen? Sure? Okay. Now, excuse me, inverse relations and functions. When we talk about inverse relations or functions, okay, we are simply switching all domain values with all relation values. So we're literally switching the x's and the y's. In other words, you must switch all the x's and the y's. An inverse, guys, think about it like this. When you look at yourself in the mirror, okay, don't you get an inverted view of yourself? Yeah, right? Things flip, right? Hello? Yeah? Well, that's great. How many of you have ever played a video game? I know that's a lie. All of you have played. You're probably playing right now during my class. So, guys, if you do, if you ever have seen a 3D image on a screen, or if you do play video games, guys, what happens is the monitor is an inverse, actually, of the image created by the components within the screen or the computer. It shoots out an image, but for us to see it, it must invert it. It doesn't happen magically. It's done like this with math. They're inverted. What else? What else? Pictures. You guys do know that when you take a, not digital, but old school photography, when you take a picture, guys, the thank you, it's upside down and backwards. Thank you. When you develop it, it gets inverted so you can actually see it. So this inverse stuff isn't just something that Mr. Moore wants to torture you with. This is real life stuff. If you ever want to make a video game or work in any computer field at all, matrices and inverses and logs are going to be your friend. So anyways, how do we do this? Very simple. My original relation, remember, a relation is just a set of ordered pairs. It doesn't have to necessarily be a function. Is 2, 3, 3, 5, 4, 7, and 2, 6. Guys, to find the inverse, literally switch the x with the y. So 2, 3 becomes 3, 2. 3, 5 becomes 5, 3. 4, 7 becomes 7, 4. 2, 6 becomes 6, 2. You literally switch out the x with the y. So if I give you a table and I say, find the inverse of this table, well, literally, switch the x and the y's, you're done, son. Done. Now that's easy time. How about this? Find the inverse of the given relation. Okay. Oh boy, I love it when it does that. So it's going to equal. What will be my first point now? This. Thank you. You're inverting it. Next. Yes. 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 That's it. That's how you invert a table. I'm sorry, my brother? Not necessarily going to get perpendicular lines, no, but you know what? I have a little bit of time. So why don't we investigate that instead of me just saying yes or no to that, brother? How about that? Let's see what we can do. Okay, let's see, my brother. Let's first graph the relation negative 2, 5, 5. And then we got negative 1, 4, 0, 3, 1, negative 4, and 2, negative 5. So just for giggles, if we were to connect these, I don't like the way that worked. Hold on. Okay, now in red, let's graph our inverse. 5, negative 2, 4, negative 1, 3, 0, negative 4, 1. Sorry. 5, negative 2. No, 5, negative. Whoa, what did I do there? Hold on, Moro. Hold on, Morito. Okay, let's do it the right way again. 1, 2, 3, 4, 5, negative 1, 2. There you go, Moro. 4, negative 1. There you go, Moro. 3, 0. Negative 4, 1. 1, 2, 3, 4, 1. And negative 5, 2. Check this out. No perpendiculars, but aren't those completely inverted? Looks like a DNA strand. Very good. Very good. That's what an inverse is, guys. Okay? The x and the y's literally just switch. Not bad, right? Now, find the inverse of an equation. It's very easy. Don't let this stress you out. Simply replace the x with the f of x or y and solve for y. Literally. Find this inverse. Cool. We're going to go ahead and literally make this x, and we're going to make the old x y. Do you see what I did there? Because that's the key right there. That's the most important part. Now from here, you got to know how to solve. How do I solve for y here, my brothers? Good. Add 2 to both sides. Very good. Thank you. Good job, guys. And then you square root to get rid of a power of 2. But remember, y equals plus or minus square root of x plus 2. Now, just out of curiosity, the first graph that we had, that was a function. Okay, because for any individual x value, you only have one y. However, is my new y equals plus or minus square root of x plus 2, is that a function? No. Why? Remember the little trick. If you have a plus or minus in front of an x, that means you're going to have two different y values for the same x, and you cannot have that. That is wrong. Feel me? Okay, how about this guy? What are the graphs of y equals 3x minus 5 and its inverse? Well, 3x minus 5, I got 1, 2, 3, 4, negative 5, up 1, 2, 1, 2, 3 over 1, up 1, 2, 3 over 1, down 1, 2, 3 over 1. So that's my original. Let's get the inverse. So it equals x equals 3y minus 5. Add the 5. Thank you. Great job, kid. I am hearing you. And then y equals x plus 5 over 3. So y equals x over 3 plus 5/3. Be good, boys. God bless you. So 5/3. It's going to be 1, 2, and like a third, right? It's like 2. Positive, yeah. So we've got 1, 2, and a third is about there. And then we go up 1 over 3, up 1 over 3, down 1 over 1, 2, 3. And that would be my inverse. This 1, 2, 5/3. It is a little bit less. You're right. Thank you, kid. So actually 1 and 1/3. So about there. There we go. And then I go up 1 over 1, 2, 3, down 1 over 1, 2, 3, and about there is my inverse. How would I find the inverse to this guy? What do I replace this f of x with? X. And what do I replace this x with? No, with y. How do I solve for y? Cancel out that square root of 2 by squaring both sides. X squared equals y minus 5. Add the 5 to both sides. Y equals x squared plus 5. And that is my inverse. And perfect timing. Yes, sir. Yes, sir, when you're inverting the x and the y. Yes, sir, my brother. No, sir, you do not take the coefficient. You literally, you made that y an x, and you literally made that x a y. Thank you so very much. May God bless you. Hope you learned a lot. Thanks again, guys. Have a great day.